So in this video, we're going to look at 11.5 and 11.6. So talking about predictions from the linear regression and then how to determine if we have an outlier or not. And so we're going to use example 11.6 to illustrate this. So same example we've been looking at with the exams of students. So we had some exam scores for students' third exam out of 80, and we compared that to the final exam score that was out of 200. And we came up with this equation here. So y hat is equal to negative 173.51 plus 4.83x. And we would like to predict the final exam score of a student who has a 66 on the third exam. So this is going to be very similar to what we did in an algebra class. We're going to just plug in 66 in for x, and we're going to get 145.27. And so that's going to give us a prediction of what we would anticipate someone with that score would get. Let's do another example here. What would we predict the final exam score for a student who scored 90 on the third exam? So similarly, we're just going to go ahead and plug in 90 into our equation, and we get 261.19. Now, there is a slight problem here that the max score for the final is out of 200. This is predicting that we're going to get 261, right, over 261. So what's happening here? And so the main issue here is going to be with a phrase called extrapolation. So when we actually look at the table of values, so our x values here, notice the smallest is 65 and the largest is 71. If we try to make a prediction outside of this, we call that extrapolation. Our linear model is only good for values within here. Once we try to predict values outside of here, it ends up being a bit more difficult. So these models are only good for values within here. So, for example, if we're doing some kind of profit and you're trying to figure out what a company might make 20, 30 years in the future, that's very difficult. That's a hard thing to do. So the further out you go, the less consistent or accurate our model is going to end up being. So let's also talk about how to get outliers. So in 11.6 here. And so an outlier is a value that's extremely far away from the rest. But we're dealing with two variables this time around. So how exactly does that play out? And so we're going to still use the example of the exam, so relating the third exam to that final there. And so our outlier technically is a value that stands out further than 2 standard deviations. And so to look at this image here, what we're trying to figure out here is, and so here we identified an outlier, and we're trying to see that if this distance right here, right, we got to come up with a certain limit. And if anything goes beyond that distance there, then we're going to consider it an outlier. And that distance is going to be 2 standard deviations. And we're going to use both x and y variables to get that. So when we subtract our actual value from the predicted model from y hat, that's going to give us an epsilon value, which is that distance right in between there. And so our standard deviation is actually what we call the sum of the squared errors here. So our SSE divided by n minus 2. Recall, whenever we get a standard deviation, we're trying to find those differences. And we typically square it in order to make all those negatives positive so we could add them up together. So it comes from that. And so if that epsilon value, so that residual, that difference there, is larger than 2 standard deviations, then we have an outlier. So that's kind of the gist of it here. So from our calculator, we were able to get our S value. We could use our equation, but we're really going to depend here on technology to do this. So our S is going to be equal to 16.41 roughly, our standard deviation there. And so that's what we're interested in. If this distance is larger than 2 of those standard deviations, we're going to consider that an outlier. So I'm going to take the first data value, the one that we identified as an outlier, and the first thing we want to actually do is figure out y hat here. So what is the predicted value? So we plug 65 into there and we get 140. Now what we want to do is we want to find that error, that residual, which is 175 minus 140. So that's going to give us 35. And since 35 is larger than 2 of those standard deviations, we say that that is an outlier. Now, technically, you want to do this for all of the data values here. So we would find our predicted and then find our residuals for each one of them. And then we find out that the only one that is actually larger than 2 standard deviations, or 32.82, is going to be 35. So all the other ones are contained within that bound that we made, and we only have one outlier.